So let's start thinking of an example where we start putting all that information all together. Let's say over here on this site, there's a bunch of trees. And we've got those trees and they've been marked out by some surveyor or something, so we have a pretty good understanding of that's where the trunks of those trees are. Well, knowing where the trunk is very useful for obvious reasons, but the other thing we'd want to know is where the drip line is. So that's the edge of the tree, where the reach that the tree has with its branches. And so you would start to map out where that actually is. And the reason that you would be thinking about that is that that drip line probably represents, it's not going to be an exact science, but probably represents roughly where the root ball is in the ground. And so by starting to sort of map that out, if you have decided that you're trying to save these trees and you want to keep that as something on the site, you can't do any excavation from the drip line edge, because if you do start excavating, you're going to be cutting back on the roots, and eventually that's going to get to a spot where it's going to damage the trees and they'll start dying over a span of time. So you start looking for what are the things going on in the site that are important. Well, we just said there's a bunch of trees, we want to keep those trees, therefore there's an edge to where any excavation can go. And that's going to be a meaningful thing to know early on in the design process. We've already talked about how this is a wet zone in here, so that's something we know that we have to either deal with in some very particular way as a design thing, or we just stay out of that wet area. And then let's say we were going through the soils report and maybe there's sort of not very good soils in this area, but there are pretty reasonable soils over in this zone. Well, that's going to tell us pretty fast that we're probably not going to want to build exactly right there, but if we have a better set of soils, that this is probably our sort of main zone of where we're going to want to start to think about where our building would go. Is this something that needs to have a leach field for a septic system? Well, that would impact our choice. Does it have to have frontage to a street front? That would impact. Understanding the orientation from the sun, that if north is up here, that we're going to have more sun in certain areas than we're going to have in other areas. Understanding that in the morning there's going to be shadows from these trees, so that's going to be sort of useful and telling. So kind of the point here is that you literally are putting all of this down onto some sort of site plan graphic analysis. And you would start with very rough drawings, very simple, sketchy, like this is what we know, this is something we want to keep, this is something that is less important, here's where the good soils are, there's where the bad soils are. So you're putting all of that down onto this thing so that you can have a conversation, and then you're able to have a conversation with the soils engineers, you're able to have a conversation with maybe a civil engineer, you're able to have conversations with structural engineers about what kind of foundation systems might make sense. This is all that kind of early discussion. You're not going to design the foundation. You're not going to figure out, well, okay, it'll be exactly 15 inches thick slab with a, you're not going to get into that detail. That's not what you're doing right now. Right now what you're doing is, it's like, what are the big picture items here? What's driving our decision making? And you're going to put all of those things together into one set of documents. Now, it doesn't have to be one document, everybody does it a little differently. The point is, for the NCARB purposes, you're collecting all of that information and you're documenting it both in the individual analysis, but then also in this sort of graphic sum total analysis. So you're able to put all of that information together, and then that allows you not only to have your conversations with your team, engineers like we just said, but also that there's sort of comes a point where you're building a case to be able to have the conversation with the client, with the owner, say, look, this is the logical choice. This is why we're here. It's not just some random decision. This has to do with so we can save money on foundations because we have better soils. We're not in the drainage area, so we're not going to have long-term maintenance problems. We're not in the shadow of the trees or endangering the trees, so that we're still going to get good solar radiation onto the building and have something to look at with these beautiful trees here. Like, you're sort of telling a narrative story, and you're sort of telling the story of where the building goes, right? So kind of using these sort of different analyses, putting them together into one document so that you can have this very clear set of understandings that everybody can get behind, And that will be then a useful tool for having those conversations and making the final set of decisions. When you do a document like this, it doesn't mean that, okay, everything points to this location right here. It's like, okay, except maybe it's just not a very good view from there. Like, maybe the view really needs to be from over here. Well, that's okay. We can build in the poor soil area. It just means it's going to cost us money. So we're making a conscious decision where it's not just that things are happening to us and we find out later, it's like, oh, I guess that's going to be more money. It's that we are saying the view is more important than the extra $20,000 in cost for the foundation. That's a reasonable decision, if that's the decision you want to make. So the point of these things is not to tie your hands. The point is to create the tool to have a conversation. So all of these things are separately analyzed and then brought together so that you see the impact of one thing to another. Any specifics on a site would then sort of play in. So the specifics of the soil, rock outcroppings, specific view lines, you would literally just draw them all right into this one document so that everybody can see everything all together. It's always best if you can also stand out on the site and sort of walk around and feel it, holding one of these things, so you really get a sense of, yeah, this is the good soil, this is the bad soil, this is the place where we think the views are going to be, are the views good? That's not going to be part of the NCARB exam. You're not going to expect you to talk about walking onto the site, but it's that same concept, right? You're looking for what is the determining tool that helps you have that conversation so that you can then make your decisions for moving out of programming and out of those early phases of thinking and into schematic design, because that's the difficult leap, is from the concept into an actual set of designs. And that's really what we're talking about here, is how do you have that sort of basic idea, these sort of big picture thoughts about site, and now we're going into an actual design. We're saying, actually, we're going to put it there.